Good morning, everyone. My name is Mike Umstead. I'm with Gomez and Sullivan Engineers. So I went to SUNY ESF. I'm not an engineer. I studied fishery science. So during undergrad, I worked at TIBS, the Thousand Islands Biostation. I graduated in 2023, and I've been with Gomez and Sullivan since. This is my first AFS conference, at least with the New York chapter, so I'm really excited to be here. I really enjoyed a lot of the talks. So I'm here today to talk about a study we did using eDNA to try and detect American eel on the Racket River. So the goal of the study was to evaluate the distribution of American eel in the lower Racket River, and also use that to inform the needs for upstream eel passage. So there's several hydroelectric projects on the lower river. And so this study was performed for the Sissonville Hydroelectric Project, which is the 8th dam upstream from the confluence with the St. Lawrence. So here's a little background on the life history of American eel. This figure might look familiar from one of our plenary talks. So adult eels live in the freshwater rivers and they migrate out to sea to spawn. And then larvae drift along the current and become glass eels by the time they hit the coast. And so sometimes they can climb up dams under certain conditions. So here's a couple of examples. These aren't from the Racket River, and this can really only happen under certain conditions. So on the right, those are elvers. So they can really only climb up the concrete when it's slightly wetted. So if there's too much flow, they can't. They won't be able to go. And then these are yellow eels on the left, slightly larger. So here's our study area. So as you can see, the Sissonville project is the 8th dam up, and then the first 5 dams have had eel passage installed since 2009. And so the study area is focused on the lower Racket River, which stretches from the confluence of the Racket River with the St. Lawrence up to Potsdam. And so there's some historical surveys that do show presence of eels. So there was some electrofishing done that shows there were some caught in the 90s and early 2000s. But since, and then there was also eel passage installed on the first 5 dams. And so some were caught before the eel passage was installed, and then since installation, only 2 eels have been caught, kind of the downstream end. So then more recently in 2021, there was a study by the Nature Conservancy that found a couple detections of American eel. At sites A and B. So here are the methods for the study. Borlex is the owner of the Sissonville project. They consulted with DEC and U.S. Fish and Wildlife to develop the sites and methodology. So at each dam, there were 4 sites upstream and downstream. And then so this is what was used to collect the eDNA. This is Smith Root Citizen Science Sampler. So pretty much has, so instead of like collecting water samples and bringing them to a lab, the filter is kind of there at the end of the vacuum. So the water gets sucked up and the DNA gets filtered. So then the filter is saved and put in a cooler to get sent to the lab. And so at each sampling site, the areas with better cover were selected for sampling. And then other data collected at each sample site, the weather, water quality, so temperature, dissolved oxygen, flow from nearby USGS stages, substrate, so like boulder, sand, cobble, stuff like that. And then also visual observation goods. So the samples were sent in to a lab to get processed. And that tested 8 replicates per sample using polymerase chain reaction. So then along with each of the 4 samples above and below each dam, there was a control, and that was so at each of the, so there were 9 dams where the DNA was collected above and below each one. So then 4 samples and 1 control at each of the 18 sites gives 90 samples that were sent off to the lab. And so here are the results. There were no visual observations of eels and no positive eDNA detections of American eel. Some of the replicates indicated potential presence. So